start off, I am in Dr. Mafuz's research lab at the University of Tennessee. So I have my bachelor's and my master's in biomedical engineering. But this is probably the most exciting for me because when I was in high school, I was determined I was going to go to college and major in forensics. Something's kind of changed that plan a little bit, but this is really where my passion kind of lies. So some of the work that I do with Dr. Mafuz is really in bridging the gap between our biomedical engineering program and our anthropology department at UT. So what we're going to do today in this first hands-on session is go through the segmentation process, taking a CT data set of a live patient cranium, and then we're going to segment it and ultimately end up with a three-dimensional model. This is really the basis of most of the work that we do in our research lab. So in Dr. Mafuz's lectures this morning, he's given a little bit of a basis on some of the orthopedic implant design and some of the other projects that we've done. And this is where my role in our lab comes in to manage our undergrads and our student workers to really develop these three-dimensional models on a regular basis. So we've done studies with the femur, with the radius, a number of bones in the body, and right now our focus is obviously on the cranium. So has anybody used segmentation softwares to create three-dimensional models before? Okay. So what we're going to introduce you to today is a commercially available program called Aviso. This isn't our software that we wrote, so you can use programs like Amira, Aviso, Mimics. There's several that are available for commercial download. Aviso is just our preference at the current moment for the features that it has and what we're interested in doing. So it's actually pretty easy, and some of the steps that we've gone through to prepare the data set today I think are going to make this hands-on session a little easier. So I believe on each of your desktops is an Aviso program, and please stop me or slow me down if any we're not all on the same page. But the one that we're going to open is just the basic Aviso 6.3. And so we can close out all of these screens until you're left with this basic open main screen. So you'll see that this screen is separated into sections. You'll have this 3D viewer, which is the very large area. You have this top area, which is called the pool. And in your hands-on instructions, I believe everyone has that. I'm going to try to follow those a little bit step by step because we really did write out every single detail of how you're going to be going through this process. And for the very first steps, we do reference the pool quite often. This is the properties area, and then here along the bottom you have the console and also the help browser if ever you get kind of called up and need some help on this. So what we want to start out with is to go up to the green button in the pool and press Open Data. And I believe Imam has loaded this data set somewhere on your desktop. Is that correct? So if you can change your drop-down menu to find the desktop on your computers, you should be able to hopefully get to this M64 folder. So if you open this M64 folder, you'll find a folder called DICOMs. You can open that folder, and these are our DICOMs. You just want to click on the very first one, scroll to the very bottom of the page. You can hold down your Shift button and select the very last one. Once you have all of your DICOMs selected, you can hit Load. And then OK, because it likes to keep reminding us that we have a trial version. So did everyone get their DICOMs loaded? Yes. So you're going to go ahead and hit OK. So for these particular set of DICOMs, we have, like I said, we've already done some image processing, and we've already done a cropping of our data set. So I have this, I believe, on page 3, how to crop your data set, which is in the segmentation instructions, but we're actually not going to do that since we've already done it for you. But I am going to go ahead and go through it really quickly just to show you what you would do, but this is not something that I need you to do right now. So The reason that you would use the cropping of the data set is when we, in a research lab, we take a lot of the dry bones from our anthropology department and we lay them out in a specific format, and then we go to the hospital and we CT scan those. So if we're doing a particular project, say, where we just want to look at the right femur, we have a set of DICOMs that's sent to us from the hospital that's 2,300 images, and we don't want that. We need to simplify our data, and for a primary reason of data management and file size, we need to reduce that. So what we will do is we will crop out everything else that we're not looking at and just save that particular femur. So we've already done that. But what you could do in Aviso is you can right-click bounding box and you can right-click this Ortho Slice, and it'll bring up an image of our cranium. Normally, like I said, it would be 2,300 images long, and you'd have to scroll through. So you can kind of play with your 3D viewer a little bit. You can, in this properties box down here, you have a slice number. You can scroll all the way through your slice number. You can kind of get a view for what you're looking at. Here in your properties menu, you have this orientation option as well. You can change which view you want to look at. Again, you can kind of scroll through. And so this is where you would make a note of which slices correspond to the boundaries of the bone that you want to look at. And then if you were to eventually decide what those were, you could then go back up to your data set here. And once you click on these data sets in this pool area, they kind of go into a shadow mode so that you know what you've selected. But you can click on this crop tool, same image that's in most programs. And then what you could do is put in a number. You can pick whatever you want. And you'll see how it corresponds to the actual data set here. What's surrounded in the green boxes is actually what you've cropped down, and everything outside of those green boxes is actually what would be cropped out and no longer saved. So you can see how if we have an entire body, just cropping it out to one small little section would be pretty helpful, and then it would also reduce the file size.
Excuse me, could you just go over where the crop tool is again?
Sure. So if you go back up into the pool, and you click on the green, your main data set, to make sure that it's selected, this properties area will light up.
Oh, I see, and then the crop tool is below.
Right. So in the properties area, you can just click on that. So we've already gone through this, and you can kind of see, if I just cancel this out, we've been a little generous in our main boundaries of this Ortho Slice. We could obviously go through and we could remove some of this posterior side of the scan. And we actually didn't leave much room at the top, so we're pretty good on that boundary. But you could, depending on your preference, go through and crop out a little more. But for what we're doing today, I think we're pretty good right here. So for those of you that did do this, all you want to do is click on these three documents that are up there, this glow, bounding box, and Ortho Slice. Once you click on one, you can just Control X, rather, and it'll remove it. So we want to get back to where we were when we originally loaded the data set so that we're just left with our DICOMs. So as everybody just has the DICOMs. So for this particular data set, and this varies for every single scan that you're going to have, these CT scans that were captured were low resolution, and we needed to convert them to a high resolution data sample so that we would have a very accurate 3D bone model. So we've gone through some image processing steps that aren't always necessary. So what we're going to do first, before we even open up the data in order to do the segmentation, is we have to resample the data. So if you are to right-click on your data set, and you want to go down to where it says Compute. So in your instructions, it says in the properties area, you're going to select cubic width 8 from your filter drop-down menu. So in your filter menu, you just scroll down to cubic width 8 and just select that. And then we want to click on the voxel size, which is in the mode option. So click on voxel size, and we want to get rid of all of the numbers that are currently here, and we are going to change them all to 0.8. We're trying to make it a high-resolution scan, so you'll see that the voxel sizes were very large, and we're reducing them, and then we're going to do an interpolation to kind of smooth out our data. So this is mostly important because we've used live patients. So when we work with the Anthropology department and we just send the bones through, we obviously scan those with as high resolution as possible, and then we have these bone models that are highly accurate, and we can't do that with the live patient, so we have to do some image processing to try to fix that. Exactly. So you just want to hit apply. So in your instructions, it says that a new file is going to appear in the pool, and it has this .resampled file name. So if this is all popped up, you now want to make sure that you click on that one so that your properties area changes once again. And we know that we're working on the resampled file rather than the original. Okay, great. So this particular data set doesn't have any dental implants, and we did that for simplicity reasons. This person really, I believe, doesn't have any teeth, so it's beneficial. But the next step that we normally would do is we would right-click on our data set again. We want to go down to Compute, and then we want to select Cast Field from the Compute option. And the reason that we're doing this is the metal in the CT scan, sometimes from the cavity fillings or any other dental implant, would cause this severe scattering in the mouth that would overcome the mandible and some of the other portions of the skull, which was a pretty severe problem for some of our data sets. We would do this to try to reduce that metal artifact effect. We would keep with that unsigned char 8-bit, so you actually don't even have to click on it. This was the option that we were using for this particular data set to try to reduce that metal artifact. But we would just hit apply just so this cast field option was applied to our data set as well. So now this third modified data set should pop up with the extension, the 2-byte. So does everybody have that as well? Okay, so this is where we're actually going to begin our segmentation process. So if you make sure that you click on this third modified data set, you want to right-click once more. You want to go down to Labeling, and then you want to select Label Field. And this is actually going to open a brand new segmentation editor in Aviso. So is everyone here? So if you start at page 4 of your instruction sheet, it kind of starts there and gives you a basic overview of this segmentation editor. So you can tell that the entire user interface of Aviso has now changed. So you still have this 3D viewer, and it's split into the 3 views, and then also gives you where each slice is in the top left-hand corner. This very top section is called your materials section. We're not going to edit this much today because we're not using a number of materials, but if you were segmenting multiple bones, or if you wanted to separate the crania from the mandible, then you could create a number of materials and then you could separate those. For the purpose of what we're doing today, we're just going to segment everything into one main material. You have your tools window, which is where all your segmentation tools come into play. So we're going to go through these a little bit. So beginning on page 5 is a brief description of all of these tools. So it shows you an image of just this toolbox area. Your segmentation tools. And We're going to do this mostly for the cervical vertebrae that we're going to try to remove from our model because we cropped it. I'll start off by these zoom buttons here. You can kind of zoom out. You have zoom and data window. You have a magnifying glass with a plus and a minus, and that'll zoom in your data set or zoom out. But you can see from the bottom two images that several of the vertebrae are also included in this, and we want to try to remove those. So this is where our segmentation tools are going to come into play to try to go through and remove this. So there's several on here, and they're not all described in your instruction sheet because some of them just aren't that relevant to what we're doing. You will notice that you have this all slices and then this current slice and then a checkbox that says show in 3D. And this is one of the really, I guess the most tricky things about this Aviso program is that the 3D button and the all slices option can save you a lot of time, but it can also set you back greatly. So when we are spending hours doing some of these segmentations for ones that are very difficult, you can use the 3D button to select several materials at once, and I'll kind of show this in a second. But you can also accidentally select them and delete them. And there's currently no undo button that we're aware of. So we have done these for hours before, and you're tired and you just kind of mess up a little bit and you click a button and your whole segmentation is gone. So we kind of put a little feature in your instruction sheet to just try to, it's really hard, especially when you're first beginning, but try to always be aware of whether or not you're doing the segmentation process in 3D or if you're doing it just for the single slice that you're looking at. It gets a little tedious and it's a little sometimes annoying if you do mess up. So you have the clear button, looks like an eraser. So if you ever have anything that's selected, you'll see that it'll show up in red and you don't want to use that. You can go ahead and click the clear button and it'll just undo your selection. And then you have this plus button and the minus button. And what these do is these take that selection that you have that's highlighted in red and it will either add it or subtract it to the material that you have highlighted at the top. So this really comes into play, say, if you were to separate the mandible and the cranium. You can select a piece of material or you can select an area on your image and then you could select, say, crania or mandible and then add it or subtract it there. Your segmentation tools, which are described at the bottom of page 5, start with your arrow. You have this arrow which basically picks any region. Right now, there's no boundaries on your image, so if you select anything, it's just going to select the entire image. You also have this brush tool, which is probably the most convenient of everything. Your brush tool, if you select it, has the set sizes that you can select, but it also has this toggle bar, so you can make the brush tool as big or as little as you want. And what the brush tool will do is if you have a boundary, you can just draw on your image and decide what you wanted. So, for example, if you were doing this by hand, which would be very difficult because it's not that accurate, then you could add that to the crania, and you can see that you now have this purple kind of boundary. But we'll unselect that since it's clearly not where it's supposed to be. So you also have what they call the lasso tool. And the lasso tool is pretty convenient because it will actually auto-trace along the edges of similar pixels. So if you were to select the lasso tool, I always use this auto-trace option. It's the best when you're doing this lasso. And you can click in one area and it's, maybe I should zoom in. You can click along an edge. I don't know if you can see that little, can you see this yellow line? You can see how it just kind of hugs the border of the white area. And it really won't go out into the darker space. So it's fairly accurate in being able to detect the edges. And then the last tool that I think is useful is what they call this blow tool, which is the very last one. You can change the tolerance and the Gauss width, but we don't modify that much. And what it'll do is you can start in the center of a selected range of pixels, and you can just press down and then reach out, and it will continue to grow. It'll do this region growing for a set of pixels that's within that same area. So these are all the three main tools that are kind of described at the bottom of your page 5 instruction sheet. So what I mentioned at the start of this is we've kind of gone through already and done some image processing, some steps so that the data set looks the way that it does. And we did this in order to create it in a high resolution scan, but this also made our segmentation process very uniform, so that normally there's some user interpretation, I guess, in their segmentation process, but we kind of eliminated that by being able to do this next step, which we're going to do is thresholding. So I guess this will be on your page 6 in the very beginning, or in the very middle, I'm sorry, that says to proceed with the segmentation. So it says that in the 3D viewer, you will click on selection at the top here, and you're going to go down and you are going to select threshold. And you should have this new threshold box that kind of pops up. So what I would recommend is moving it out of the way of your 3D viewer a little bit, because when we put in some values, it's actually going to modify the images on your 3D viewer. So what you want to do is you want to select your minimum value to 150, and your max to 255. Does everyone have this window up? You want to select all slices, which means that every slice that we have loaded into a mirror, it's going to do the same thresholding process for every slice. And you'll see that in the top left, it created this model, a rough mesh of the selection, or everything that we have selected in red so far. So once you have all slices selected, you just want to go ahead and hit apply, and you'll hit close, and everything should still be selected. Are we all okay here? So you'll see that inside in your materials is already selected. It's kind of highlighted. If it's not, you just have to click on it. We want to add this to what we're just going to call the inside material. And you can go ahead and hit the plus button, and it will change it to the color of that material. You can also you can change the names of these if you want. So you can, when you have multiple materials, you can do that. You can also change the color if you wish. It might be easier. Red is sometimes easier to see against the gray background, so maybe that'll help on the screen. They're kind of the same. So you'll see that the majority of all of the bone is selected, and then it also has this headrest that's in the back of the patient's head that's selected as well. So what we want to do is we want to go through now and manually kind of edit this and make it as good as we can using those segmentation tools. So the first thing that I would do, normally I wouldn't, just as a personal preference, I would not segment using all three of these open views because I like to zoom in and see what I'm doing. But I think that it's helpful for this session at least to kind of see what's happening in all three views. So if you select your pointer tool, just your arrow from this toolbox, and if you zoom in a little bit, so I zoomed in twice, maybe 3 times, or maybe just 1 time would be better, to about when you're in this area. What I want to do first is I want to remove that area, that metal, or that whatever that material is that's laying in the back of the patient's head. So if you use your tool, your pointer tool, you can click. It's probably the easiest to see in this bottom left view. You want to try to click as closely and as accurately as you can into this small little red line. If you click outside of the red line, it's just going to highlight the rest of the material in the background. If that happens, you can just hit your eraser button again. And if you have to zoom in or move around, you can do that as well. But you want to try to select this background so that it highlights. And you can know that you're accurate when that whole little kind of semicircle appears in the top left. So did everybody get that? So we don't really care about this, right? It's not part of our segmentation. It's not something that we want in there. So what we can just go ahead and do is hit the minus button because we just want to go ahead and remove it. And you'll see that it's no longer has that red boundary around it. So we want to continue to do this for as much of the data set as we can. In scrolling through, you'll see, I think it's easy in this view, you'll see this small section that's just in the center here. Obviously, that's not something that we want to have. So you want to kind of scroll through these three views and try to find any things that are out of place. You'll also see in the bottom left, in the very, very bottom corner, you have what's probably a piece of the clavicle or some sort of piece of the shoulder that's there. And what we want to do now is go through and try to remove as much of these areas that are not part of the cranium of what we're going to be doing the analysis on. So what I would recommend doing, because now it's really difficult to kind of see in these three views, is if you're zoomed out enough where you have this background around your slice, you can click in the empty space in one of them. Say if you click in the top right, which is that XY, you can click in this empty space. And along this top toolbar here, this is your 4 viewers. You can do 2, you can do 2 vertical, and then you can do 1. So if you click here and you know that you've selected this one, you can click 1, and now you just have the 1 viewer there. And you can zoom in, modify your window so that you can scroll through and see the data set as much as you want. So what I think we're going to do is I'm going to kind of let you guys go for a second and try to scroll through these, and I'm going to walk around and try to help you. So what we want you to do in either of these 3 views is to find a slice, say like this one, where you have these little artifacts that aren't part of our segmentation. You want to go through and remove those. Continue to find things like that and remove that from that inside material until all that we're left with is the basic crania. And one of the main problems that we're going to face, and what's probably going to take us the longest, is to try to remove those vertebral bodies from this scan. You can see, of course, in this bottom view, what is the most difficult when it comes to these live patients is the vertebral bodies really have no separation between the base of the cranium and the first C1 and C2. So you can kind of modify your data window a little bit, and we're not really going to do that. So it really kind of is up to the user's interpretation of where the base of the skull ends and the vertebral bodies start. So that's going to be the most difficult part. But if you just want to play around with a viso for a little while, you can play with these 3 windows. You can kind of scroll through. Use your pointer tool, if anything's separated, to select an independent body and remove it. And then I can come around and just kind of show you guys how I would recommend doing other pieces that might be more difficult, like the vertebral bodies. So I'll just walk around, but if you guys have any specific questions, just call me on over and I can help you. So I should kind of clarify this, I guess. Because I said there's no separation between the cranium and the vertebrae, you're not going to be able to just click on it like you do those little areas that are kind of floating around in the brain. So what you're going to have to do is pretty much use your paintbrush tool, and you're going to have to, for a select certain set of slices, you're just going to have to go through and use that paintbrush tool, highlight the area that you want to remove, and then remove it. So this is just when it comes in to be a little more tedious.
Question.
Sure.
If you click on a selected area, but you didn't mean to or you didn't want to, how do you unhighlight it?
You can just click this eraser button, or clear, like the letter C on your keyboard also means clear, so you can just click that clear button as well. So if you look up here now, I have it set up to a place where you can see the main shape of that vertebral body there. And so I know that this is separated from my skull, and I know that that's a vertebral body. So if I wanted to take my paintbrush in this view, and I can just start kind of going over, and I don't have to be accurate here because I want to make sure that I cover that entire area. You can see, even though I did one slice, you can see in these bottom two areas where I've highlighted. So you can actually see how it corresponds to these two slices here. So you can see that I'm pretty far down because I'm not anywhere really near the base of the cranium. But when I highlight it in that one area, or in this one slice, I can then go and I can remove it, and it's no longer there. And there should also be, if it was where I had a vertebral body, you would see a blank line in all three slices. So it doesn't matter which view you do this in. I could do it here, and I can take this, and I can come all the way down. And you'll see here I've highlighted this whole slice. And you see how it corresponds to this one slice over here. And so I can erase it in that image as well. And so it doesn't really matter which view you're working in. You can choose to view. That's why I think it's a little easier to sometimes click on one window and zoom it in. But you can do it on any slice you want and just go through and start removing what you know is not part of the cranium. Yes?
Then how can we select from this slice to this slice and put it all in instead of just a plain shield?
Great. So there's many tricks in a visor that save you lots of time. So ideally, what you can do is this 3D button that we've mentioned is going to select materials that are touching one another, that are continuous in multiple slices. So if you come in this, say, top XY plane, and if you cross it out like I did, where there's, I just removed a slice, you have this whole volume that's, say, the top portion of the cranium. Then I cut off a piece of the vertebrae, and I'm still going to have the rest of the vertebrae that's still in another volume. But because I separated this one, the two are no longer touching. So what you could do, which will save you a lot of time, and hopefully, I don't know if these two dots that are right at the top of that particular vertebrae will be a problem, but we can see. So what you could do is, which direction am I going? I'm going up. So let's find my slice here. I've got all of this that's all touching, and then I have my slice that I kind of deleted. So now I can go here, so I'm moving posteriorly, and I should be able to 3D select the vertebrae, which is great, because you can see that I've selected it up there, and it's hard to see. I think for me it's hard to see up here, but you can kind of see that it makes like a mesh of the vertebrae that I have. You can see in this view that it's selected the vertebrae at the bottom. And so you can scroll through and you can see how you see all of that red that's selected. So I've just now selected that entire volume. Same thing here. I've selected all of these vertebral bodies that lie between, and this is probably the best view. You can see here, this little blank one really tiny slice is the one that I removed. So now you can 3D select this entire body. And what you just have to do is go through and hit your minus button and all of that's gone. And it'll be gone in all 3 views. So you just have to go and scroll through. So this is where it's very difficult, and this is where your paintbrush will probably have to come into play when you have these edges that are they're just continuous. So you would have to come in knowing your knowledge of anatomy and go through and make the decision on what's vertebral body and what's the cranium. So when it comes to be this very general area, I guess, that's when you would use your paintbrush to be a little more specific and kind of go through. Does that make sense? So what's great about a VISO is it seems like it can be a little time consuming in a VISO with all segmentation programs, but there's lots of shortcuts. Just like thresholding was a major shortcut, if we didn't threshold, you would otherwise have to use these tools to go through and select all of those pixels that are the bright white, that are the cranium. So there's lots of tools where you can do this, and that 3D button does come in handy quite often so that you can do stuff like that. So because we actually have already segmented this model, and we have it saved into the folders on your computer, so we're going to be using that 3-dimensional model for the next session after lunch. So we don't actually have to finalize these. But you can, I guess, get a feel for just the difficulty in trying to separate out the cranium, base of the cranium versus the vertebrae. So I'm assuming that you guys are not going to want to finish these when we come back for lunch, because we're just going to move on. So if you get to an end point of where you are now, we're just going to close out where your current segmentation stands, and we're going to make a 3-dimensional model of it just to finish up the process of how you would do this. So once you guys are to a point where you can stop, you just go ahead and hit close, and it'll take you back to this main user interface. If you had your labels, one thing that I tell our undergrads all the time is to save, 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 because the 3D button, with that 3D button and being able to erase your entire segmentation, you want to save it as often as possible, and we just try to get in the routine of doing that, so in case you do mess up, you can kind of just go back to your last saved file. So if you were in this labels area, it's just like any other program, you would just go to File and down to Save Data As. And if you were to do that, it just comes up, same name that's currently in the file, which you see in the pool, is just the labels. You can rename it if you want, otherwise you can just go ahead and hit save. So now we're back to closing that out anyway. So what we're going to do is create the 3-dimensional model. And so in order to do that, you want to right-click on your labels file, and you want to go down and select Surface Gen, so that this is going to generate your surface. From this smoothing drop-down menu in the properties area, you want to select none, and then you just want to go ahead and hit apply. Once you see this new surface file has popped up, so you can click on this, you can right-click and select Surface View, and a surface view of your file should actually open. Now, I didn't do much to mine, obviously, so I still have all of these specs that are scattered around, but all of yours should probably look different depending on how much you've removed. So on your mouse, you all have that roll button as well. You can roll while you're in this area, and it'll zoom in and zoom out, so you can kind of see what your model really looks like. And if you really zoom in, you can kind of see how it's really rough. It's really, really rough. And so what we need to do next is go through a series of smoothing steps in order to get this skull model down to what we feel is smooth so that you can view it, but not too smooth because we don't actually want to remove the features that we're looking for. So the first thing that we're going to do from this surface file that we have, you'll see here that the number of faces, Dr. Mahfouz says that we were using files that have 100,000 faces, but this one has over 1 million right now. So we're going to go through a series of steps and try to reduce this file from over 1 million faces down to 100,000. So you want to select, just click on the surface file. So you want to select this simplifier tool Looks like a bunch of crossed lines with a triangle in the middle. And once you click on that, you'll see that this new option pops up, and you'll see that it has a number here for faces. And so in your instructions, it actually says that you just want to automatically skip to 100,000 faces. But we did this yesterday, and it doesn't provide you with a model that's as smooth as we would like. So what we would recommend you doing is going through this process several times to reduce down. So what I would recommend starting at is 500,000. So once you enter that number into faces, you want to select the Preserve Slice Structure option directly under Simplify Faces. And then you want to go ahead and hit Simplify Now. And the bar, your loading bar at the bottom, should go through. And what it's doing is it's simplifying all the way down to that number. So now that's updated, and you'll see that it's reduced it to close to 500,000 faces. So the next step that we want to do is right-click on your surface file, and you want to go down to Compute, and you want to select Smooth Surface. So you want to right-click this surface file. Once it's down to 500,000 faces, go to Compute and Smooth Surface. So just let me know if your computers are not running as fast as this one. So once you're there, you want to input 20 iterations, and just go ahead and click Apply at the bottom. So you'll see, I don't know if yours is the same, but we have so many files now that I need to scroll down. Because a new file's been generated that has this smooth name at the end. And so what this one's done, we went from over 1 million faces to 500,000 faces, and we've smoothed it. So if you want to, you can right-click, you can select Surface View again, and then you can come up to this original surface view that you had from the over 1 million faces, and you can click on this little orange box. And what this is going to do is hide the original one. And you can see how smooth it went. So what we would do is we would just repeat those last two steps to reduce the number of faces to 100,000, and then do that smooth surface step one more time until we ended up with a file that's at 100,000 faces. But once you have this smooth model, you can kind of scroll through and look at all of the features that are on this particular cranium. And here you can actually see that mine, if you can kind of tell, still has an entire C1 that's still attached to the base of the cranium. So this is pretty much just where you would end up with the actual segmentation process. You would end up with this model that's 100,000 faces, and then you would then take this model and input it into the software that we've developed, which is what we're going to go over after lunch.